Hey everybody, this is Kamal. I'm co-founder at AccelerateAI. We bring to you GitHub tips for data science professionals as part of this series. If you have been following some of our previous videos, you would have noticed we have covered a very important video around 6 key points for having a compelling and powerful profile in data science, right? And there, I would give a reference in the comment section in this video as well. If you notice there is one dimension about community presence, and GitHub is part of that. It's very important, not just from a source code or from a coding presence perspective, but much more than that, the narrative, how we build our data science profile, and so on. So we'll be talking about those things. So the agenda is like this. First, of course, we'll look at the motivation. Then we'll talk about creating and maintaining repository in GitHub, then understanding the workflow. Then we'll see how we can be social and collaborating. Then we'll talk about capturing a use case experience, then dealing with issues, levels, milestones, all of these things. And then, of course, a standard folder structure specific to the data science field. So without further ado, let's dive in. When we look at why do data scientists need GitHub, right? There are many points. One, of course, you look at it from a collaboration perspective, because data science is a field where it's more of a experimental approach, iterative approach kind of field. So collaboration is very much needed amongst team members. Then configuration. Obviously, as part of the overall deliverables, we need to make sure how we configure, how we can automate some of those things, how we can dynamically change the parameters as part of the configuration. So that's very important. Third, a structured coding approach or a step-by-step approach and maintainability of it. So we can use GitHub as a, of course, version control system, but much more gel with each and every tools and technology platforms that we have. Then four, the workflow planning. We will see how effectively we can plan the different various environment-wise code movements through that. Then better reproducibility. Now, reproducibility is very important in data science. If there are 4-5 team members working across geographies or different places, then it becomes very important that the code that we are building as an individual, when we integrate it, the reproducibility is important from that perspective, and also across the teams, presenting to customers, stakeholders, partners. Reproducibility is very, very important from a data science perspective. Then, of course, model management, model monitoring, extremely important in the cases where we are using MLOps, machine learning, operationalization. So obviously, GitHub plays an important role there as well. And of course, last 2 points, but not the list, the version control and release, which is a default there, and then security and protection from the authorization standpoint and so on, right? So obviously, looking at all of these dimensions, I think there's enough motivation for us to focus on and then see how we can leverage these as a tool and build to the fullest in terms of representing ourselves as a successful data science practitioner. When you start looking into the point of creating and maintaining a repository, there are various things. When you start looking into a new repository to be created, you have various options such as public, private that you can choose. You can create it as a private. You can have your draft version. You can create it and then later, change it to public as well. The moment you are doing public, obviously the entire world can see it, and you want to make sure it is in proper condition and then the final version of it and so on. There is also a point to be noticed that you have to initialize the repository with a readme.md file, the readme file. This is where a long description or a proper narrative can be maintained as part of the repository and the subfolder structures accordingly. And there are also other suggestions like you have to choose a license if it is applicable, then .gitignore kind of a file and so on. So those are also important. You can also do an import a project from different place to the GitHub as from your old repository's clone URL. If you know that, then you can clone that and bring it to your repository. Here, I have also given a sample snapshot of a data science repository. One, if you look at, there are multiple branches that we typically see. Master is the default branch, and then you can have multiple branch one, branch two, branch three, test branch, and all those things, depending on how your organization of the team structure, how your objectives are in the business, and what you're trying to do. Based on all that, you can create the structure accordingly. And then, of course, when you are creating a repository, there are different folder structure. We'll see that, but this is just a sample representation of how you can capture some of these. So this is about creating and maintaining the repository. Then let's look at the GitHub workflow for data science projects specifically. So you have a master branch, and then you create a branch from it, because obviously master branch is a parent branch or the default branch. And then we want to create multiple branches depending on whether it's a pre-prod environment or a staging kind of a branch, or there are multiple team members working on it, so that we want to have a playground branch and then integrate it into some place of a staging or individual staging branches, and then can bring it to the master. So that way you have to create a branch. Then you can add commits to it, because if there are multiple team members, you can have different changes to your code snippets, and then you can add commits to it. Then you can open a pull request, because before we move it back to master, we want to open a pull request as a process. Then, of course, we discuss and review our code base or the changes that we have done within the team. Then we deploy our code. We used git checkout, local or production. And then, of course, we use git merge and then push it to the master branch. So you have to use, if you're doing that, you can use it from the command prompt. You can use it from your GitHub desktop or some other interfaces as well, web interfaces also. And the way the process it works is git merge, then git push, and then it goes on to the master branch. So this is the entire process of the workflow, the way we can plan for the data science project. Now, if we look at a scenario where you have one master branch, assume that it's your production default branch, and then you have three branches, assuming three team members, right? Team member one, team member two, team member three, and each one of them would have a work in progress branch and a final branch. Final branch is essentially, for that team members staging area before they want to push it onto the master branch. So each one of these team members, they can have a playground area or a developer area, which is WIP, mentioned here as an example. And then you can move that to the final branch. The way we have defined the process here is get the latest code from your master into all the respective branches, because obviously everything is the final version or the current version in the master. Then we want to take that and make development changes to the respective branches by respective team members. Then we discuss within the team, what are the changes? Is it going to impact to other team member or the entire program and so on? And then the team agrees and approves the change. Once that happens, then we can push the latest code or multiple code snippets into the master. So that's kind of a scenario that you can use here. In addition to that, there could be alternate option also. You may say that you would have all the three team members would have a work in progress branch, and then they get back to a staging area. There may not be three final branches the way we have shown it here. There could be a one staging area or a pre-prod branch kind of thing, and then that you can move from there to the master branch. That also can be followed. Now, looking at how we can use this to be social and collaborate. So some of the key things that you would have noticed or you will notice is one, how can you follow some of the other users? Because if you are in a GitHub, if you explore, you can follow and watch. You can also do a star to some repository that you want to learn. You can fork it so that you can bring it to your area and then start getting value from it. Trying to see if there are some changes that is happening by that particular user, then you want to follow or refer that branch. So a lot of these things that you can do. And then, of course, the trending of repository, you can go to GitHub Explore and then search for some particular area that you want to do research and analyze and try to learn from it. And you can do the trending repository as well. So that's about be social and collaborate. Then we're going to look into the capturing the use case experience. So here, or the project experience, what we would recommend is you can create something kind of a product or project initiative or product initiative kind of a branch, and there you capture some of your individual use cases or projects that you're doing. Ideally, if you look at here, we have created a snapshot. The readme.md file would have a snapshot of all of these, where we are kind of listing down the project or product initiative names, then description about it. Then what are the data science techniques used? Have you used any classification, regression, or different type of techniques, neural networks or something? And then, of course, what is the business outcomes, impact, and value that was created as part of it, right? So that's one. And then once you go to each and every, let's say you have listed down 5 projects, and then each of the project, let's say one of the example here we have shown is, if you go to that particular page, you can create project1.md, project2.md. MD stands for markdown file. And there you can have each of the projects in a respective readme.file, MD file that you can create. Here you can mention what is the project name. For example, we have given an example of clustering patients for specialty pharmacy. You can do that, client industry, whether it is healthcare or something else that you can mention. Then what is the nature of the project? Is it revenue generation? Is it for maintenance or cost savings? Is it for some kind of a transformation? Accordingly, you can mention it. Then your primary role on the project. Are you a data scientist, data engineer, or data visualization expert, or analytics track lead, and then so on, right? And then technology area. What are the different areas, whether it is generic end-to-end data science, machine learning, clustering, unsupervised machine learning, and so on, right? And then you can focus on 4 broad parameters as a suggestion: business environment, planning, solution development, and solution implementation. In business environment, what you can capture is what is the stakeholder of the business or the customer, what is the business objective of it, what is the goal that you're trying to solve as part of the project. So you'll have to mention all about that. And then in planning, you can mention in your entire life cycle, what is that you're following? Are you following a crisp DM kind of methodology? If that is the case, then what are the assumptions that you have taken? How are you looking into your exploratory data analysis, and so on, right? And then solution development, you can look into the actual feature engineering and the model development, model evaluation, those part, how you are doing it. What are the best practices, what are the lessons learned that you can focus about. And solution implementation, finally, you can capture the end result, how it is presented to the customer, the stakeholders or partners. And more importantly, at least all of these project or use case that you're capturing, it should have at least one best practice, one lessons learned. That has to be there. And the moment you narrate that and keep it, you'll make sure that you will feel confident of what you have done in the last 3-4 months of one project or one use case, right? So that way you can maintain it on an ongoing basis as you get exposed to it. If you have not done for a client project, fine, you would have done as part of your internship, you would have done as part of your learning process, some one-year program or whatever, accordingly you can capture it. Okay, so you can also then talking about dealing with issues, and then of course levels and milestone issues is a very simple thing that we can create as part of that repository. And then there could be list of issues we can tag to them with levels. Now levels could be anything. You can use whether it's a EDA related issue or feature engineering related issue or model algorithm related issue or model evaluation related aspect or deployment issue. That way you can categorize and structure it effectively, right? So those type of things can be managed well within the repository, within the set of project that you're working on. And levels are a great way to organize different type of issues, right? Issues can have as many as levels you want, but you can filter them by some of the things. So if you want to capture that, yes, I want to see what are the issues at this stage of the project. If it is feature engineering related issues or EDA related issues or initial analysis, that way you can manage it effectively. Then getting to see about a data science project folder structure, right? This is a suggested one. You can do something similar. If you look at it, what we have mentioned here is, you should have a config kind of a folder. Under that, you would have YAML file with the configuration where you have some of your parameters that you're using it as part of the entire project. Then you have a requirement.txt file. Here you should have all of your packages or libraries. So for example, in Python, if you're using NumPy, Pandas, Matplotlib, scikit-learn, different other packages, let's say for time series, you're using, let's say, Prophet or LSTM, STM, whatever that you're using, all of these, you can mention that with a particular version if it is applicable. And that way, when you are running the entire code in a particular environment or your local machine somewhere, it goes through to implement or install those things first, so that you don't get issues later about a particular package missing in that current environment, that kind of thing. Data is where you can manage the source data input files in terms of CSVs or database files or something like that. Then data prep is where you would have some of your functions that you're writing to export the data or transform it, or some common utilities that you're using as part of it. Libraries, if you're connecting to some kind of databases, whether it is DB2, Oracle, SQL Server, or PostgreSQL, and so on, you can write script of the connection string so that you can better effectively manage there in one place, and you can invoke it accordingly in other programs. You can also have the query to when you're reading from some of the database tables or writing into it, those things can be done over here. And then the source or SRC folder, you can have all of your model files, the files that you're training. Maybe you may have multiple algorithms with different experiments as well. So you would have algorithm 1, algorithm 2, algorithm 3. So there are 3 model train files or training related files. Then there could be another one with evaluation, and then another one for prediction. Of course, there is one more that you can think of in terms of output.py kind of a file where you write your output or the result to a particular file, or into a cloud object store or a database that you can also mention. And you would anyways have the readme.md file where you elaborate or narrate some of these in a structured manner, and then license if there is anything applicable, Apache 2.0, whatever that you can mention. So this is the ideal recommended, practical folder structure that you can use in a production setup. So coming on to the key takeaways, building and maintaining the GitHub with code plus narrative is important. It's not just the code, you should have the narrative. Then you demonstrate your projects in a structured manner end to end. You can have those in some of the points that we have mentioned, so that whatever experience that you have in past projects or use cases, you can capture them well and in a defined manner. Then you have to get yourself familiar with the GitHub commands, workflows, issues, milestones, release items, all of these that you can check through, so that when you're actually doing it, it makes much of a sense. Then keep collaborating with other users. Look for trends. Look to see, start a particular repository which you feel is really excellent, and you are referring to that to solve some of your problems, right? And this is the whole purpose of always a lot to learn or pick up from the community, right? That's the advantage of it. And then you can create a special repository with the same name as your GitHub username. Let's say your GitHub username is ABC, and you're creating a repository of ABC, then that's a special repository. And whatever you write in the readme.md file there, that will show up on your landing page. So that's a good way to plan and put that on your landing page as a canvas. That's about it. Those are the key points that I've summarized, that we have covered. Hope you have enjoyed this. If you have any questions, please feel free to put it on the comment section as part of this video, or you can reach out to us in our email ID given here, and you can search for all other videos that we are publishing. Request you to subscribe this channel, and you'll get some of the important stuff that we keep on releasing in this channel. Thank you so much.